Explanation: imagine a water faucet. Instead of letting water spill everywhere, we put the faucet inside a sturdy box that has a handle, a knob, and a safety lock. In object-oriented programming, the box is class, the faucet is file stream, and the handle, knob are the methods that let us open, read, write, and close the file. By wrapping the raw stream, just a bunch of bytes, inside an object, we keep the details hidden. A child only needs to know how to turn the knob, not how the water travels inside the pipe. This hiding of details is called encapsulation. Technical depth: the class stores internal state such as is open, position, and buffering mode. These fields are private, preventing external code from corrupting the stream. Public methods: open parentheses, close parentheses, read open parentheses, buffer close parentheses, write open parentheses, buffer close open parentheses form the public interface. The implementation may use std-fstream, java.io.fileinputstream, etc. Example: open parenthesis C++ close parenthesis colon. Class file stream open brace. std-fstream stream semicolon. Bool open flag equals false semicolon. Public colon. File stream open parentheses const std string ampersand path comma stdios colon open mode close parentheses open brace. Stream dot open parentheses path comma mode close parentheses semicolon. Open flag equals stream dot is underscore open parentheses close parentheses semicolon. Close brace. std size t read open parentheses char star dst comma std size t and close parentheses open brace. If not, open flag throw std runtime underscore error open parentheses quote file not open quote close parentheses semicolon. Stream dot read open parentheses dst comma and close parentheses semicolon. Return stream dot gcount open parentheses close parentheses semicolon. Close brace. Void close open parentheses open brace. If open flag stream dot close open parentheses semicolon, close brace, tilde file stream open parentheses open brace, close parentheses semicolon, close brace semicolon. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. Think of a family tree where the grandparent is a generic file class. Its children are more specific: text file, binary file, CSV file, and JSON file. Each child inherits common abilities like open and close from the parent, but also adds its own special tricks. The base class defines the template methods for resource handling and declares abstract read record and write record that subclasses override. Text file overrides line-oriented parsing, handling newline and platform-specific encodings. Binary file works with raw byte buffers, exposing read bytes and write bytes. CSV file adds a tokenizer that splits on commas while respecting quoted fields. It may provide parse row vector of string. JSON file incorporates a JSON parser library. Read object returns a language native map. Example: Java. Abstract class file base implements auto-closable. It has a protected random access file named RAF. The constructor public file base takes a string path and a string mode, throws IO exception, and assigns RAF to a new random access file with path and mode. It declares an abstract method process that throws IO exception. It implements close method that throws IO exception and calls RAF close. Then class CSV file extends file base. Its constructor public CSV file takes a string p, throws IO exception, and calls super with p and read mode. It overrides process method that throws IO exception. Inside process, it declares a string line, and while line assigned from RAF read line is not null, it splits line by comma into calls and handles them. This hierarchy enables Liskov substitution. Any function accepting a file base can work with a CSV file without modification. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. Imagine you have a universal remote that works with a TV, a fan, and a lightsaber. You press power and it knows which button to send for each device. In object-oriented programming, a polymorphic interface is that universal remote. We define a common set of actions, like read and write, in an abstract class or interface called file.io. Every concrete file class, such as text file or binary file, implements these actions in its own way. When your program calls file.read, it does not need to know whether the file is CSV or JSON. The correct version runs automatically. Technical depth. In languages with interfaces such as Java or C#, we declare public interface file.io open brace, byte array read throws IO exception semicolon, void write byte array data throws IO exception semicolon, close brace. Each concrete class implements these methods. The compiler resolves the call at runtime via dynamic dispatch. Adding a new format, for example XML file, only requires implementing the interface. Existing client code stays untouched, the open-closed principle. Example in C#, public abstract class file.io open brace, public abstract task byte array read async open parenthesis close parenthesis semicolon, public abstract task write async open parenthesis byte array data close parenthesis semicolon, close brace, public class JSON file inherits file.io open brace, comment JSON specific parsing close brace, public class binary file inherits file.io open brace, comment raw bytes close brace. Client code, async task process open parenthesis file.io file close parenthesis open brace. var data equals await file dot read async open parenthesis close parenthesis semicolon. Comment common processing close brace. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. When you borrow a pencil, you promise to put it back after you finish drawing. If you forget, the pencil is lost for the next child. Exception handling and resource management work the same way with files. RAI resource acquisition is initialization in C++, means that when you create a file object, it automatically opens the file. And when the object goes out of scope, like when you leave the room, its destructor closes the file, the pencil is always returned. In Java, try with resources does a similar job. You open the file inside a try block, and the language guarantees close runs even if an error occurs. RAI relies on deterministic destruction. The file handle destructor contains if fp then fclose fp. Try with resources translates to a hidden finally block that calls close. Nested resources are safely closed in reverse order of acquisition. Function copy takes source string and destination string, opens input file stream with source in binary mode, opens output file stream with destination in binary mode. If either input or output is not good, throw runtime error, cannot open files, copy contents. By streaming input buffer to output, both streams are closed automatically when leaving scope. Try with resources opening buffered reader for in.txt using UTF-8 charset read each line. While line is not null, process line buffered reader is closed automatically even if an exception occurs. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. An immutable file descriptor is like a sealed envelope that tells you the address of a file, but you can never change the address once it's written. Because nothing inside the envelope can be altered, many kids' threads can read the envelope at the same time without fighting. In programming, making the descriptors fields final, which means unchangeable, allows threads to share it safely without needing locks. If a thread needs to write to the file, it uses a separate writer object that owns its own lock, ensuring only one thread writes at a time. This design prevents race conditions where two kids try to scribble on the same page simultaneously, keeping the data clean and predictable. Public final class file descriptor open brace. Private final path semicolon. Private final open option array options semicolon. Public file descriptor constructor takes path p comma open option varargs ops close parenthesis open brace this dot path equals p semicolon this dot options equals ops dot clone open parenthesis close parenthesis semicolon close brace. Public path get path open parenthesis open brace return path semicolon close brace. Public open option array get options open parenthesis open brace return options dot clone open parenthesis semicolon close brace. Close brace. Readers obtain a shared file channel in read-only mode. Writers use a reentrant lock inside a file writer wrapper. Public sealed record file descriptor open parenthesis string full path close parenthesis semicolon. Public class file writer open brace. Private read-only object underscore lock equals new open parenthesis close parenthesis semicolon. Private read-only file descriptor underscore desk semicolon. Public file writer constructor takes file descriptor d arrow underscore desk equals d semicolon. Public void write open parenthesis string text close parenthesis open brace lock open parenthesis underscore lock close parenthesis open brace file dot append all text open parenthesis underscore desk dot full path comma text close parenthesis semicolon close brace close brace close brace. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. Think of turning a Lego house into a picture book. Serialization is the process of taking an in-memory object, the Lego house, and writing its parts, brick, colors, positions into a file format like JSON or binary, so you can rebuild it later. Deserialization does the opposite. It reads the file and rebuilds the Lego house in memory. OOP helps because each class knows how to turn itself into a series of bytes to JSON to binary, and how to rebuild from those bytes from JSON from binary. By keeping the logic inside the class, we avoid mixing file layout details with business logic, just as you would not want the Lego instructions printed on the wall of your bedroom. Technical depth. Implement serializable interface Java or iSerializable C# to control the process. For JSON libraries like Jackson or JSON, use reflection but can be overridden with @JSON creator or @JSON property. Example: Python with data classes. Import data class as dict fields from data classes and import JSON. Define a data class called point with fields xFloat and yFloat. Define a method to JSON that returns JSON dumps of as dict of self. Define a static method from JSON that takes data string, loads JSON into attrs, and returns a new point constructed with the unpacked attributes. Binary serialization may use struct pack with explicit format strings. The size and endianness are part of the contract, making the process deterministic and fast. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. Explanation: a template method is like a cooking recipe that tells you the steps: preheat, mix, bake, cool. The main steps are fixed, but some parts like the exact spices are left for you to fill in. In file handling, a base class can provide a template process file that opens, reads, processes, and closes a file, while subclasses supply the specific process line or parse record logic. Technical depth bullet: abstract base defines. An abstract class named fileProcessor defines a final method process that takes a string path and may throw IO exception. Inside the method, it opens a buffered reader for the given path, reads each line in a loop, and calls handle on each line. It also declares an abstract protected method handle that receives a string line and may throw IO exception. Subclass implements handle for CSV, JSON, etc. Strategy pattern lets the algorithm vary at runtime. The context holds a reference to a read strategy interface. The read strategy interface declares a method apply that takes a path and returns an input stream, possibly throwing I/O exception. Buffered strategy implements read strategy with an apply method that returns a new buffered input stream for the given path. Mapped strategy implements read strategy with an apply method that maps the file into memory as a read-only byte channel and returns an input stream. In the usage example, a variable named strat is assigned a mapped strategy if the flag use mapped is true, otherwise a buffered strategy. And then an input stream is obtained by calling apply on the chosen strategy with the path to data.bin. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling. Performance of input-output can be thought of like water flowing through a pipe. Throughput, how many bytes per second, depends on the pipe size, block size, and the pressure, CPU speed. Throughput equals block size times 8 divided by seek time plus transfer time, where seek time is the time to locate the file on disk, like walking to the faucet, and transfer time equals block size divided by bandwidth. If you increase block size, you reduce the number of seeks, similar to using a wider pipe to pour more water at once. Measuring real-world numbers, for example, 100 megabytes per second on SSD versus 30 megabytes per second on HDD, helps you pick the right buffer size and decide between synchronous versus asynchronous strategies. Plotting throughput versus block size often shows a curve that rises quickly then flattens. The sweet spot is where extra buffer size gives little gain, just as a pipe bigger than needed does not make water flow faster. Empirical formula often used. Effective throughput equals block size divided by seek time plus block size divided by disk bandwidth. On SSDs, seek time approximately 0.1 milliseconds, bandwidth approximately 500 megabytes per second. Optimal block approximately 64 kilobytes. On HDDs, seek time approximately 5 milliseconds, bandwidth approximately 150 megabytes per second. Optimal block approximately 256 kilobytes to 1 megabyte. In code, one can benchmark with Java NIO files, read all bytes versus buffered input stream with varying buffer sizes and plot results. Asynchronous I/O can hide seek time by overlapping computation with I/O, effectively increasing throughput without changing the physical parameters. Practical tip: because the checks are cheap, always use the correct specifier. You gain safety for free. Kid-friendly analogy. Think of a school playground. The rules who may use which equipment are posted on a board before recess. The teachers, which represent the compiler, read the board and stop kids from breaking the rules right away. Once recess starts, which represents the program running, the kids just play, they don't keep checking the board every second. The board only matters when the teacher is watching, which represents compiling.